Okay, guys, so as you can see, I upgraded my whiteboard now. So now I have the electronic one. I decided to use now the whiteboard of the Zoom. I found it to be very practical, and I think you guys are going to appreciate it a little more. It has, I think, it's more legible now, my writing on it. So, and again, if you have, guys, any questions on the material that I cover in these videos, you can always ask me during my lectures that we have. They're not face-to-face, unfortunately, but we have online lectures. And because of what you guys got on the last exam, I think this lecture has been very effective. And you guys, it looks like most of you have been doing a very good job on your side. So let me start now chapter 10. So we pretty much have 2 more chapters left till the end of the semester. So I'm going to start with chapter 10. And so let me take it now to one of the most important topics of chemistry. And this is the topic of what's called stoichiometry. Eventually, once we get to about the middle of, when we get to the middle of the chapter, that's where we're going to delve into this part of the material. Now, the chapter 10, the title of the chapter 10 is Chemical Calculations Involving Chemical Equations. And to be very short, this is what's called stoichiometry. So I will, once we get there to that particular topic, I will point you guys to that topic again. I will explain again what that means. So let's start chapter 10. So it starts with the law of conservation of mass. Now, what I'm, like the way I like to teach this chapter, I like to teach it holistically. And so I'm going to definitely do all of the problems here in this chapter. As I explain, you guys now, you see the way I teach. As I explain the material, I always solve the problems, guys, as I go. All right, let's start. So we're going to start with 10.1. This is the law of conservation of mass. Conservation of mass. All right, what does it mean? Now, it means that if you have a chemical reaction, and if you start with a certain mass of the reactants, once the reaction is finished, and you start calculating how many grams of the product I got at the end of the reaction, it should be absolutely the same as the number of grams of the reactant that you started with. All right, let me give you an example of what I mean by that. Let's start with hydrogen gas. And what I'll do actually, if you guys remind me during the lecture, I did in my lab reaction of hydrogen with oxygen. I did it a few days ago. Just remind me, guys, I'm going to pause this video as a demo. And so when you combine now hydrogen and oxygen, the product is the H2O liquid, water. Now, so what does it mean, guys, law of conservation of mass? It means that if I start calculating the total mass of the reactants, and by the way, the reactants are always written on the left-hand side. Reactants. And the products, guys, always written on the right-hand side. And so what does the arrow mean? The arrow means either produced, or yields, or produced, or produce, yields, produces. Produces, you start with the reactant and then you get the products. You get the products here. So now the reactants, of course, they yield the product. But if you have one reactant, let's say decomposing, it will be yielding, guys. It will yield the product here. So in other words, again, guys, here you got reactants. The arrow means the reactants should really put now, if I put the plural here, I should put yield and as many, right? Produce. So that's what the arrow means, okay? And now, so the reactants produce or yield the products here, products. In this case, it's just the product. but usually you have several products, at least usually one, but you may have two, you may have more than two, you may have three. Now, so, all right, so how does the conservation of mass, what's going on here? Where is the conservation of mass? All right, so remember guys, you know how to determine now the molar mass of this H2. You go to the periodic table, you got now one mole of H2, right? So 1 times 1.008 grams in here, right? But guess what? You got two of them, right? So let me just erase this real quick. Hold on. Okay. So let me just also move this a little further down. Just give me a moment. So it's 1 mole of the molecule, but also don't forget you got 2 moles of the atom. So we need to calculate total mass of this, right? So that will be now, let me just make it a little simpler here, guys. A little simpler, hold on. Let me just remove this 1. And again, once we get more complicated, I'll show you how to deal with this in a moment. All right, so you got 2 moles of the atoms, but 1 mole of the molecule is the total. So it's going to be 2 times 1.008 grams. So that will give you 2.016 grams. And then oxygen here, you got 1 mole of the molecule, but 2 moles of the atom. 2 times 16.00 grams. That will give you guys 32.00 grams. Now, what I'm going to do next, I'm going to take this plus this, because that will give me a total mass of the reactants, guys, on this side, on the left-hand side here. So that will give me approximately, I don't need to go crazy here with significant figures. I just want to, guys, make, my point here with the conservation of mass concept here. Okay, so that will be approximately 32 plus 2. Let's say it will be 34 grams on this side. Okay, let's go now to this side. Let's do the same thing now. We're going to find out the total mass now of the product here. Okay, so now again, 1 molecule of H2O. So now, but you got 2 moles of atoms, right? 2 moles of atoms. Let me just erase it so that 2 moles just implies 2 moles in here. 2 moles of H will be 1.008 grams, will be 2.016 grams. And you got 1 molecule, 1 mole of molecules, and then 1 mole of atoms here. So it will be just 16.00 grams. I'm going to add this plus this. And so total mass will be here 2.016 grams plus 16.00 grams is nothing else as, oops, made a mistake. Hold on. Will be nothing else as 16 plus 2, it's about 18 grams. Look, 18 versus 34 grams. What's wrong with this picture? Well, remember I just, guys, talked about conservation of mass. I said, anytime you have a certain number of grams of the reactant here on the left-hand side, you must have the same number of grams of the product. But look, we got a discrepancy here. We got a problem here, guys. You got 34 grams here and only 18 grams here. What's the problem here? And the problem here, this equation is not balanced. Not balanced. Okay. So how do we balance it? What's the purpose against a balancing chemical equation? If you don't balance the chemical equation, you will violate one of the fundamentals law of nature, which is conservation of mass. Conservation of mass, guys. And so that's why, in order to be compliant with this law of nature, guys, this is the most important law of nature, one of the most important laws of nature, conservation of mass, you must balance, guys, chemical equations. All right. So let me go back now and let me balance this chemical equation and see if we now have the same mass on the left-hand side as on the right-hand side. So let's do it. Okay, so I got 2 moles of hydrogens, 2 moles of hydrogens right here, this 2. This is okay, this is balanced here. But I only have 1 mole of oxygen atom here, 1 mole. But here I got 2 moles. So what am I going to do now? Well, I have to balance it. And the way, guys, be very careful. I'm balancing. I'm going to put a 2 in front of this. What does this 2 mean now? This 2 now mean that you literally have 2 H2O molecules. Now, what if I balance it this way, H2O2, and I say, well, you know what, oxygen now is balanced. The problem with this, just putting 2 in here and saying it's balanced, is that you're forming an absolutely new substance. This is new hydrogen peroxide. And this is not the same as water. But when you do this reaction combining hydrogen and oxygen, you are not forming hydrogen peroxide here, guys. You're only forming water. So that's why you cannot balance chemical equations, very important here, by putting these little tiny numbers indicating the number of moles of each atom present in the molecule. And you cannot do this. This will be wrong, guys. So that's why I want to put a 2 in front of the molecule. All I'm saying is that you got the same molecule, but now just two of them of the same. Okay, awesome. So now I got 2, I do distributive property now, guys. 2 times 1, I have this little 1 here, just bear in mind. Because remember, when we don't put anything here in the bottom of this, on the right-hand side, as a subscript, in the bottom of this atom here, if we don't put anything, that implies right away you got a 1 in here, okay? So you got 2 times 2. Oh, you got 4 hydrogens now, 4 hydrogens. But here you only have 2. So what I'm going to do now, I'm going to put a 2 in here to balance it. So 2 times 2 now, 4 hydrogens. 2 times 2, 4 hydrogen. Hydrogen is balanced now. I have the same number of hydrogens on the left-hand side as on the right-hand side. Okay, great. Now, let me go back now to oxygen. 2 times 1, distributive property, guys. Don't forget, 2 times 1, 2 oxygens. Aha. Here you got 1 times 2, 2. Now it's all balanced. This is all balanced now. All right, let's check now the masses. Let's see if our conservation of mass here actually worked after we balanced the chemical equation. Let's do it now. Okay, let's calculate now the masses on the left and right-hand sides. Okay, so let's do it. So you got 2 times 2. You got 4 total, 4 moles of hydrogen atom here. And 4 now times 1.008 grams will give you, well, look, let's not go crazy. Let's say it's approximately 4 grams, let's say. Again, I'm just want to make guys a point here, conservation of mass. I'm not going here now with the craziness of significant figures here. I'm not being too crazy about it. So just, we'll use the significant figures, guys, once the proper time comes. But this just example to make a point here. Now, okay, good. So now you got 1 molecule or 1 mole of oxygen molecules. So what is the total number now of moles of oxygen atoms? Very important here. We now calculating the mass, total mass of hydrogen here. We just did it based on number of atoms. Now we're going to do the same thing based on number of atoms. 1 times 2, we got 2 now times 16.00 grams. And so it's going to be, well, this is going to be more now, not an approximate. It's going to be actually 32. Now, what do we do next, guys? We're going to sum up 4 plus 32 grams. And what we got here is 36 grams of what? Total mass of the reactants. Okay, very good. Okay, let's go back now to this one here. So remember, guys, a balance, I put a 2 in here. Very important. Now, the 1 mole of H2O was 18 grams. But now when I balance, I got 2 times 18 now. 2 times 8, oops. Let me correct that. 2 times now 18 grams will be, 36 grams. There we go. 36 grams, guys, is equal to 36 grams. And that's why you balance chemical equations to comply with the what's called conservation of mass law, guys. One of the fundamentals laws of nature is that if you started with certain number of grams of the reactant, you must finish, guys, you must finish with the same number of grams of the products. And that's why, guys, you need to balance chemical equations. And so in the next videos, guys, I'm going to do a lot of balancing chemical equations. I'll show you some of the examples where it's easy to balance, some of them not so easy, and some of them that are really hard to balance. I will show you guys some techniques. And again, those techniques will be a little more advanced. You guys got to learn them. If you guys go into chemistry, definitely in the 151, 152 course. But for now, just remember what I just showed you guys is the concept of conservation of mass. And so first, I deliberately did not balance the chemical equation. And I showed you that the 34 grams of the reactants produced 18 grams of the products, but that violated the conservation of mass law. And so what I needed to do it is I needed to go back and balance these chemical equations and, you know, show you guys when the way the nature does it, the nature always balances, guys, the number of reactants and products. And that's exactly what I had to do it. And again, the way I balance, guys, I always put a coefficient in front of the, either it's reactants or a product. Always, guys, put it in front. I never change the little subscripts, because if you do, you're going to wind up with a totally different substance. And as a result, your chemical reaction will not be the truthful statement. You will, you know, put something as a product that actually is not being produced as a part of the reaction. All right, guys, so I'm going to see you in the next video, continuing on chapter 10, covering now the other topics.